Okay, let's jump right into this. Welcome to today's Explainer, where we're unpacking a technological shift that is rapidly crossing over from sci-fi fantasy right into our daily lives. We are taking a journey today from the most intimate, visceral human sense we have, the sense of touch, all the way to a multi-trillion-dollar industrial boom. Let's get started.
So I want you to imagine this. Imagine feeling a lump on a patient's neck, diagnosing a potential mass, but you aren't even in the same physical room as them. It sounds completely impossible, right? But the thing is, this isn't science fiction anymore. This is the very real, very new frontier of haptic telemedicine.
And this breakthrough is literally happening right now at Texas A&M University. Researchers Dr. Pijuan Yu and Dr. Rebecca Friesen just landed a $1.5 million grant from the National Science Foundation. And their mission is wild. They want to add the physical sense of touch to audio and video telemedicine. I mean, we've clearly mastered the video call, right? But these researchers are building the tech to digitally transfer physical, tactile sensation across massive distances. So how does this actually work in practice? Well, here are the micromechanics of it. Picture a nurse in a rural, isolated clinic doing a physical exam, and they're wearing this highly specialized sensing glove. As they press on the patient's neck, that data transfers instantly, in real time. Then, maybe hundreds of miles away, a remote specialist rests their finger on a haptic display. Using a cluster of actuators, this little device essentially acts like a tiny shape-shifting robot against the doctor's finger, perfectly mimicking the pressure and feel of that lump. Now, Dr. Yu had a huge light bulb moment about this while working with stroke patients who had actually lost feeling in their hands. He realized that capturing human perception, not just building, cool robotic arms, is the ultimate frontier of this tech. As he put it, these haptic applications are meant to assist people, not replace them. It's really all about empowering human healthcare workers.
Section 1. Defining meaningful extended reality.
Just to make sure we're all on the exact same page with the vocabulary here, extended reality, or XR, is the umbrella term. It covers virtual reality, where you're totally immersed in a digital world, augmented reality, where digital elements are just overlaid onto our real world, and mixed reality, where the digital and physical stuff actually interacts. XR is the term that captures that whole shebang. A recent editorial from Frontiers in Virtual Reality hit the nail on the head. Researchers are pivoting hard toward what they call meaningful XR. We're seeing an absolute explosion of studies proving real, practical applications here. This is way beyond 360-degree movies or games. Today, XR is a critical tool being used to improve learning for kids with ADHD, facilitate physical rehab, and even help in elder care to boost cognitive function. It's incredible stuff. So the big takeaway here is that we really need to update our perception. The old view of XR, that it's just some gaming gimmick, a console accessory, or, overblown metaverse hype, is dead. The new reality? XR is an indispensable tool for telehealth, enterprise training, and high-stakes industrial simulation. The hype cycle has faded, and the actual utility has arrived for sure.
Section 2. Finding the right headset.
Now, these massive industrial shifts require highly specialized tools. And let me tell you, not all hardware is created equal. The first major choice is the headset's architecture, specifically how it blends the real and virtual worlds. You've got video pass-through, which uses cameras to feed the real world to screens inside the headset. That gives you amazing virtual integration, but it does introduce a tiny bit of latency. On the flip side, optical see-through projects digital content directly onto transparent glass. You're looking right at the real world, which means zero latency. And that is absolutely essential for safety-critical environments. Think an active manufacturing floor or a surgery where even a split-second video lag could be completely catastrophic. Treeview Studio did this fantastic enterprise breakdown, and they pointed out something crucial. Most XR implementation failures aren't actually because the hardware is bad. It's because of a hardware use case mismatch. Picking the exact right tool is everything. If you're doing skilled workforce training, the MetaQuest 3 is unmatched in cost of performance at $499. Need extreme visual fidelity for engineering or CAD? The Apple Vision Pro delivers incredible resolution and low latency, though, yeah, it'll run you about $3,500. And for those safety-critical environments we just mentioned, like medical or hazardous industrial zones, the Magic Leap 2 provides that must-have optical see-through tech.
Section 3. Immersive learning and training. When companies actually deploy XR for training, the performance metrics are honestly staggering. Knowledge retention, up 75% compared to normal methods. Training time is slashed by up to half. And at scale, organizations are seeing a massive 90% reduction in training costs compared to a traditional classroom. Why? Because trainees in XR are actively doing the tasks, not just passively clicking through some boring e-learning module.
But, and this is a massive but, as TreeView rightly points out, hardware enables mixed reality, but software determines ROI. You could go out and buy the absolute best $3,500 headset on the market, but without custom, expertly developed software that actually integrates with your business systems, it's basically just a very expensive paperweight. The custom content is what drives those massive savings and retention bumps.
Section 4. A multi-trillion-dollar moan. Let's zoom out and look at the money, because the data from Precedence Research is explosive. In 2025, the global XR market sat at an estimated $251.6 billion. But look at this trajectory. It is projected to hit $334.5 billion in 2026, driven by a compound annual growth rate of almost 32% over the next decade. That is huge.
Which brings us to this mind-blowing number. By 2035, the extended reality market is forecasted to reach $3.9 trillion. Yes, trillion with a T. This proves a fundamental truth about this space. XR is not a fad. It is cementing itself as a foundational cornerstone of the future global industrial economy.
So, what is actually catalyzing all this trillion-dollar growth? Well, a few massive drivers. First off, the global 5G rollout is finally solving the processing and latency limits of those older, tethered headsets by pushing the heavy computing power to the cloud. Second, as we saw with Texas A&M, we're seeing massive, widespread adoption in healthcare. Third, industries like automotive are using this for virtual prototyping and supply chain management, saving millions on physical models. And finally, the permanent shift to corporate remote work is creating a huge demand for collaborative spatial computing environments. So I want to leave you with a final thought today. The tech is here, the hardware is maturing rapidly, the custom software is proving its ROI, and the economic momentum is just undeniable at this point. The question is no longer if extended reality is going to change how we work, learn, and heal. The real question is, when will spatial computing permanently alter the landscape of your own career? It's coming, so start anticipating it now. Thanks so much for joining me on this explainer, and I will see you next time.